All right, today we are going under the hood of the Pi network. We're going to look at a piece of core technology that really makes the whole thing tick. It's a process called federated voting. And believe me, it's the system that lets a massive decentralized network actually agree on stuff. So let's just dive right in. So let's start with the fundamental problem that every single decentralized network has to solve. Think about it. How do you get thousands, maybe even millions of different computers all over the world to agree on one single version of the truth? Like a history of transactions. And how do you do that without any central company, any single boss, calling the shots? Well, that massive challenge is exactly what the Pi network is built to tackle. And the key, the absolute secret sauce that allows for this huge agreement is a process called, you guessed it, federated voting. You could really say it's the hero of our story today. Now, to really appreciate just how cool this solution is, we have to understand the problem. For a network like Pi to be safe and secure, every single participant, we call them nodes, has to agree on the exact order of every single transaction. If they don't, well, you get total chaos. And getting everyone to agree on that, what's called consensus, is a massive technical hurdle. So what's the solution? Well, it's this really cleverly designed mechanism that actually comes from the Stellar Consensus Protocol, or SCP for short. Now, unlike those super energy-hungry systems like Bitcoin's proof of work, federated voting lets all these independent nodes reach an agreement safely and reliably without a central boss. And that makes it a perfect fit for Pi's whole mobile-first approach. Okay, so how does this thing actually work? It's probably less complicated than you might think. The whole thing is broken down into a really structured two-phase voting system. This makes sure that once a decision is made, it is absolutely final and secure. Let's take a look at how that process plays out. What's really interesting here is just how elegant and simple the process is. So in phase one, the nodes vote on something called a statement, which is basically just a proposed block of new transactions. Now, the crucial rule here, and this is super important, is they can't change their vote. If enough nodes agree, that statement becomes accepted. Then you move to phase two. They vote again, but this time they're voting to accept that already accepted statement. And if that vote passes, the statement is officially confirmed. So let's follow the life of just one of these statements, okay? It all begins at the unknown stage. A brand new block of transactions is proposed to the network. But right now, at this point, it has zero validation, no support. Its future is totally up in the air. Then, after that first round of voting is successful, the statement moves up to the accepted stage. This is like the first layer of security. A well-behaved node, we call it an intact node, meaning it's playing by the rules, it now makes a commitment. It promises it will not accept a different conflicting statement. It's basically drawing a line in the sand. And finally, after that second vote gets the green light, the statement becomes confirmed. This is it, the final stage. It now has the highest security guarantee you can get. The statement is now considered a permanent, irreversible part of the network's history. The whole system can now safely add it to the ledger. It's set in stone. But, no system is perfect, right? Even with this really robust design, federated voting does have one potential weakness, and it has to do with something called liveness. Now, in simple terms, liveness is just the system's ability to keep making progress, to not get stuck. So here's what that means in the real world. On one side, you have the perfect outcome, consensus. A quorum, which is just a fancy word for enough nodes, is reached, they all agree, and the network moves forward. Awesome. But on the other side, you have the risk of gridlock. This happens if the nodes are split and no single statement gets enough votes. The whole process can just stall. The network gets stuck in a stalemate, completely unable to move on. So that's the theory. But how does all this connect back to the Pi network? Like right now. This isn't just some abstract idea on a whiteboard. This is the actual system being used and tested as we speak to manage the entire network. And we know for a fact this is a huge focus for them. The Pi Core team has been actively testing and developing the system, thinking of it as a kind of constitution for the network ever since the mainnet was first announced. So yeah, it's a really high priority. So where do you actually see this happening? Well, if you're one of the amazing people running a Pi node, you are a direct participant in this. Node owners use commands to tell their node how to vote on these super important network-wide changes. A perfect recent example? That big upgrade to protocol version 23? Yep, that was federated voting, live and in action, securing the future of the network. So, the crucial point, the one thing to take away from all of this, is that this whole complex, multi-stage voting system, it all just boils down to one essential job. It's the guardian of the network's integrity. It's what makes sure every transaction is valid and that the Pi network ledger stays secure, consistent, and trustworthy for every single one of us. And that brings us to the big forward-looking question, doesn't it? We've seen how the system works. We've seen how critical it is for security and for making decisions. So the question is, will this sophisticated engine of consensus be the key that finally drives the Pi network to its ultimate goal, a fully open and decentralized mainnet? That is something we are all going to be watching very closely. Thanks for digging into this with me.